So we hear about these super powerful tools like Apache Kafka all the time. But what really makes them tick? If you want to truly harness Kafka's power, you've got to understand its inner workings. So today, let's pop the hood and really dig into the core architecture that makes it all possible.
I mean, just think about it for a second. Your ride-sharing apps, financial tickers, those endless social media feeds, they're all getting hit with this relentless fire hose of data, 24/7. And that, right there, is the exact problem Kafka was engineered to solve. The answer, as you'll see, lies in its absolutely brilliant design.
All right, so here's our game plan. We're going to start with the big picture, kind of the 30,000-foot view. Then, we'll dive right into the nitty-gritty of brokers, partitions, and replication. And by the end of all this, you're going to see exactly how these pieces fit together to create a system that's both incredibly powerful and super resilient.
Okay, first things first. Let's establish what we're really talking about here. The best way to think of Kafka is as the central nervous system for any modern application that depends on real-time information.
Now, don't let the fancy jargon scare you off. Distributed, that simply means it isn't stuck on a single machine. It runs across many. And event streaming? Well, that's just a cool way of saying it handles data on the fly, as it's happening, not in some slow batch process later. So how does this whole distributed thing actually work in practice? Well, it all starts with the fundamental building blocks of any Kafka setup, and those are the brokers. And what's a broker? At its core, it's just a server. Think of it as a computer whose entire job is to be a workhorse. It receives data from what we call producers, stores it safely, and then serves it out to the consumers who need it.
But they do so much more than just store stuff. A bunch of brokers get together to form a cluster, and this team can actually withstand failures. They manage every single read and write request, and they work together to make sure no single server gets totally overwhelmed.
Okay, to really get this, let's use an analogy that I think makes a ton of sense. Imagine your application's data flow is like a massive, bustling postal network for an entire city. In this network, each Kafka broker is like an individual post office. It's a physical hub that receives mail, holds onto it, and gets it ready for delivery. And this is where the magic really happens, right? Think about it. If your city's mail volume suddenly explodes, you don't try to build one gigantic skyscraper post office. No way. You just build more post offices around the city. Kafka does the exact same thing. Need more capacity? Just add more brokers. That's horizontal scaling, and it's what makes Kafka so incredibly powerful and reliable.
So we've got our network of post offices, our brokers. But that's only half the battle. How in the world do you sort all that mail efficiently without everything grinding to a halt? Well, that's where partitions come in. They are the absolute key to handling massive volumes of data at incredible speeds.
See, in Kafka, all your data is organized into what we call topics. Things like, say, user clicks or order updates. Each of these topics is then split into one or more partitions, and a partition is basically just a log file. Data gets written to it in the order it arrives, and this is critical. Once it's written, it can't be changed. It's an immutable record.
Let's zoom in on what that means. New data is always added to the end. It's appended, never changed. Now, if messages have the same key, like a specific user ID, Kafka guarantees they'll all land in the same partition, which is crucial for processing things in order. And here's the real kicker. Different consumers can all read from different partitions at the very same time. Hello, parallelism!
Let's jump back to our postal analogy. Imagine one of your post offices gets completely swamped with mail for one super popular address. What do? You don't just make one clerk work faster. You assign a whole team of clerks to work on that mail simultaneously. Partitions, they're those parallel mail clerks, letting Kafka process a mind-boggling amount of data for a single topic, all at once.
And this is the big takeaway right here. Partitions are Kafka's secret sauce for achieving massive throughput. This is literally how a single topic can ingest and serve up millions, even billions, of messages without even breaking a sweat. It's all about that divide and conquer strategy.
Okay, so we have our post offices, our brokers, we have our parallel mail clerks, our partitions. Things are running smoothly. But what happens if a post office, burns down? How do we make sure that no mail gets lost? This brings us to Kafka's built-in safety net, replication.
Replication is pretty much exactly what it sounds like. It's a fantastic feature where Kafka doesn't just store a partition in one place. Nope, it creates and maintains identical copies or replicas of that partition on other brokers across the whole cluster.
Now, not all these copies are created equal. For every single partition, one of its replicas is elected the leader. The leader is the boss. It handles all the live read and write requests for that partition. The other copies are called followers. Think of them as the dedicated backup crew. Their only job is to passively copy everything the leader does, staying perfectly in sync, so they're always ready to become the new leader at a moment's notice if something goes wrong.
And this brings us to the final brilliant piece of our analogy. For every single important package, our digital postal service makes certified copies and stores them at different post office locations. If one location goes down, no problem. The copies ensure that no mail is ever lost and can still be delivered.
So the takeaway here is simple, but it is so profound. Replication is what gives Kafka the high availability and the data durability that it's famous for. A server can crash, a network cable can get unplugged, but because of replication, your data is safe and the system just keeps on running.
So, there you have it. We've got brokers for scale, partitions for parallelism, and replication for safety. Now, let's tie it all together and talk about how configuring these things is a really critical balancing act.
This table really lays it out perfectly. You want higher throughput? Awesome, just add more partitions. But you have to be aware that this can add a bit of management complexity. Okay, what if you want rock-solid reliability, like never lose a byte reliability? Great, increase your replication factor. But just remember, that's going to cost you more in disk space and network traffic. It's always a trade-off. Ultimately, it's this elegant dance between these three core components, the physical servers, the method of organization, and that crucial safety net that gives Kafka its incredible power and resilience for handling real-time data.
And look, getting a handle on these internals, it's not just some academic exercise, it's a practical necessity. When you master these concepts, you can really design and tune your Kafka-based systems to be as efficient and as reliable as possible.
So, we've peered inside the machine. We've seen the brokers, the partitions, and the replicas, all working together in perfect concert. The only question left is, now that you know how it all really works under the hood, what incredible data-driven application would you build with it?